Hello GameMakers, this is GameMaker Rob, and in today's episode we introduce you to A-star pathing, and we also generate a path for characters to move along. So let's get started. Hello, so at the end of the last episode I said I was going to have some kind of 2D representation for what the units were going to be doing when moving, when using our nodes, that kind of thing. And this is that 2D representation. What's going on is our first battle map is being drawn in 2D. I'm not worrying about the height. I've just got green for the grass, blue for the rivers, circles for the units, and this stuff here is basically where this unit can move, and these numbers, I'll tell you about that in a minute. You'll notice how every time I change to a different unit, the grids they can move on, like this bit here I'm calling a grid, changes. It's a bit different for each one. The reason that is because we want certain things to block them. So say for example for this guy, he can't move here because there is a unit blocking him. He can't move here because this guy and this guy are blocking him. He can go 1, 2, 3, 4, or 1, 2, 3, 4 like that. So each actor has 4 movement points. So that's what these the number above these squares represents how far away from the moving actor it is. So the first square he's on is 0 because he's already there. If he wants to move here or here, it costs him 1 movement point. If he moves here, here, it costs 2, 3, and 4. And like I said, we want other things like other actors to block them from moving. And if you see this guy here, he's right next to the water, and I've decided that water is going to be impassable. So this node is marked as impassable. Basically, each one of these squares is a node. All of these are nodes. So I've said that this node here is impassable because it's water. So this actor can only go 2 squares to the right. He can't go here because it's not one of these marked squares. You can only go here. He can go 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, etc. And you'll see a different color square popping up now. When I move the cursor around, you can see like a little purple, pinkish square. I'll explain to you what that's about right now. Okay, so what is a parent? A parent is a node that will get you to the current node as fast as possible. Basically, the lowest score. So if node A has a parent, node B, whose score is 3, and then node A is found in another node neighbor list, node C, and node C has a lower score, then node C will become node A's new parent because it's faster to get to A via C than from A to B. So say for example, we look at this node here. It's got 4 neighbors. These 4, this was the start node. So it's going to be in a list to say we've already checked it. So it's going to get ignored by this one. But we're going to say, okay, well, could this node become this node's parent? Well, this node's score is 1. And this node's score is 0. So it definitely should not be the parent because this node has a higher starting score than this one. And this one would have a score of 2. If it was this one's parent, So this would have a score of 2 if it was, if this was the parent of this node. So this will never be this guy's parent. If we look at this node, so does it have any surrounding nodes with a score of less than 1? So this is a 3, this is a 3, this is impassable. So no. So that's why this is this guy's parent. Look at this one. So does it have any neighbors with a score of less than 1? So this is 3, 3, 3, No, so that's why this is this guy's parent. Look at this guy here. So this is its parent. Every other node surrounding it has a value of 4. And why we need parents in the first place is just so we can, when we generate a path, we're going to say, okay, well, we know the end node, which is, say we want to move to this square here. We know this is going to be the end node, so we'll work out the path going backwards to the start. So who is the parent of this one, which is the node which is fastest to get to here from the start? And we can see that this node here is the parent of this one because it's highlighted in pink. So then we go to this one, well, which is the next fastest node to get to, and it's this one. And then we say, okay, which is the next fastest, which is this one, and okay, which is the next fastest, this one, and we've reached our goal. This is how you generate a path. Let's start from, say, here. This is its parent, this is its parent, this is its parent. We're at the start. This is how we generate a path. Let's try a different character. Okay, so let's say I want to move to here. We can see this is its parent, this is its parent, this is its parent, this is its parent. So hopefully this kind of explains to you what's going on, why we need the nodes and what they're going to be used for. So I'm going to show you the scripts now. Okay, so if we go into the create events of obj test, we're going to have a new list. This is called list of active nodes. Basically, all the squares you could see highlighted are nodes that are inside this list. So when we are moving around, it's going to say, okay, is this node within range of this character? If so, then add it to this list. That's all we're using it for. If we then go to the end step, and then in setup battle, this region where we create nodes, we're going to add some new variables to the node. So we've added this stuff here. So we need the node to know its grid X and grid Y. We need the node to know its height, and we need the node to have a parent variable. Set it to no one to begin with. And also, like I said, in my game, I'm going to say that water or a chasm is impassable. So if I show you the 2D floor sprite, so the first image is a chasm, and 0, 1, 2, 3 is water. It's the same with isometric. So 0 is a chasm, 1, 2, 3 is water. So if the floor index is 3, which is water, or the height of the tile is 0, which will be a chasm, it doesn't get drawn, is 0, then we want to say with this node, passable is false. Otherwise, if neither of these is true, then passable is true for this node. Hopefully the way I have coded this doesn't confuse you. Normally I'd have like some braces here, but just to kind of reduce the amount of lines I was using, I just didn't use them, and that's why the else statement is where it is there. Or I could have it all on one line, like this, like that. But yeah, that's why I put it onto 2 lines. Okay, so let's minimize this now. And then in next actor, we have a new script. So it's going to be script display action nodes. I didn't call it movement because we're going to use this script to generate a list of nodes for stuff like attacking, casting a spell as well as movement. So it's not just going to be for movement. That's why I've named it like this. It's going to ask for several arguments. If you see down here, it's going to ask for a start node. So it's going to be the current actors grid X, current actors grid Y, whatever node that is in the node grid. That's going to be the start node. Range is going to be the movement, because this is going to be for movement. So we're going to say, okay, he can move 4 tiles. Then it's going to say impassable allowed. So say, for example, you want to shoot a bow, or you have a weapon that can reach across several tiles, and you want it to go across water, or maybe you have a character that can fly. Then you would have impassable allowed to be true, but for my characters, none of them can go across water, so impassable allowed is going to be false. The next one is ignore higher than. What that means is if you are trying to move from one tile to another, and the tile you're trying to move to is higher than 1, than the current. So say you're on a tile and the height is 6, and the one you're trying to move to has a height of 7. That's okay. If the one you're trying to move to is 8, then that would be higher than 1 difference, so you couldn't move there. If I changed it to 2, then you can move from a 6 to an 8 or a 2 to a 4. If I change it to a 0, then you can only move to 2 tiles that have a height of the same value from the tile you're moving from. That's what this is for. The next one, actors block. So you could see how the actors were blocking movement in that 2D representation. That's because I've set this to true. If I set this to false, then you'd be able to move through and probably land on actors as well, because I didn't do a check for that. But if you were allowing actors to allow movement, then I would do a check to make sure they can't finish on the same tile as an actor, unless you want that. I don't know, but usually that isn't a thing in this kind of game. And then last of all, we're going to use our new list. This list is going to hold all the nodes that are within range of 4 of this node here. So that's the new addition. That's every difference in the steps so far. And then if we go to the draw event, so we're inside draw cell, the draw cell region, and then under where we are drawing the floor, so line 44, line 46, we've got a new region, and we're calling it draw highlight if this is an active node. So we're going to check what node we're on. That's what this line's going to do. And then we're going to see if this node is in this list. If it's in this list, then it will return a value greater than -1. If this node isn't in this list, then it will return -1, and this won't happen. So if this node is in this list, then this is going to get drawn. It's just drawing a sprite over something else. And that's it for the draw event. If we run the game, we can test this bit now. Oh no, we can't, sorry, because you don't have the script. Okay, so let us check out the script. So we called it SCR display action nodes. Here's all the variables that we've already gone through earlier. These 3 are yellow because I'm not checking them just now. I wanted to keep the script as simple as possible when I take you through it the first time, and then we'll add these on afterwards. Okay, the only thing I need to explain really is terrain cost. In my game, all the terrain costs 1 point to move to and from. You might want to have terrain that costs different amounts. All you need to do is I'll show you. Where we create nodes, yeah. So here, you'd have like another variable saying terrain cost. Well, actually, say terrain cost. equals list etile data.for index. So basically what this means is if we look at the tiles, any tile with this image will have a terrain cost of 0. This one would have a terrain cost of 1. This would be 2. This would be 3. Basically, the higher the value, the more movement points it would take to get to it. So it'd be harder to travel across. For this tutorial, I am not going to have variable cost terrain. I'm just trying to keep things as simple as possible. I just wanted to show you what you would need to do if, because I'm sure plenty of people would want that. So leave this as 1 for now. All this does is initialize it anyway, but in the script, wherever you see terrain cost, you want to use the nodes value for that if you want variable terrain. Okay, so that's out of the way. Okay, so what this queue is for is we just add nodes to it that are in range of the character, so they have to be within 4 tiles away. And then whenever we get to that particular node in the queue, we're going to check its list of neighbors to see if they are also within range. So all we want to do is check every node that's within range of the actor and check their list of nodes as well to see if they're also in range. And if they are, they get added to the queue. If they're not, then they don't get added. That's all it's for, really. Because we delete nodes from the queue, we need to know whether we've added it to the queue at some point, because we don't want to add it and check it again, because you're going to potentially have a never-ending loop, but also you will make the time to check things increase significantly, like several seconds or longer. So we're just going to have a list to say, okay, whenever we add a node to this queue, we add it to the list as well. The queue will decrease in size. This list will only ever increase in size. We just use it to check whether we've added a node to the queue. That's it. Our list of active nodes will get cleared here because we want to generate a new list or a new content for that list every time that we run the script. With our nodes, we want to set their combined distance to 0 and say they don't have a parent. We don't really need this line here because start node is a node. We've already set its combined distance to 0. We're just doing it again. I like to have it there. It makes me feel good. So yeah, that's why it's there. Combined distance. If you remember in the 2D representation, there is numbers. That's the combined distance. The first thing we want to do before we do all of our checks is add our start node to our queue. That's what this line is going to do. And we're going to set current to no one just to initialize it. And the first thing we do, we have a while loop, which is this long. And within this while loop, so it's going to run for as long as the size of the queue is greater than 0. As soon as this queue has nothing left, this while loop will finish. So we grab the node with the lowest priority from the queue and delete it from the queue at the same time and add it to our open list to say, okay, we've added it to the queue, so we don't need to add it again. This is just making sure we don't have some kind of error. If there is an error, we're going to break out of our loop. So with every node that's stored inside the queue, we want to get their list. This is going to be a list of nodes that are the neighbors of this current node. And then this for loop is here. This runs for as many neighbors that are in the current list. So if there's 3 neighbors, this will will run 3 times. So we're going to grab the instance ID of whatever node is stored inside the list. We want to check to see if that node has already been added to the open list or to the priority queue. If it has, then this will run. All this is for is we just want to see, well, a node has more than one neighbor, which means it's quite likely that we'll have a node that's been added to the queue already, but then we'll get the same node coming up from a different node, in that node's list. And it's possible that the new current could be closer to this node than the node's previous parent. So if this current node is closer, it will have a lower combined distance score than the parent's combined distance score. If that's true, then this will run, because this node should have this as a parent because it's closer. That's all this is for. Otherwise, so this bit here means that this node has not been added to the queue and it's not been added to the open list. So we need to check it basically. So first thing is it won't have a parent because it hasn't been touched before. So we're going to set its parent as the current node. Then we are going to set the node's combined distance score, which will just be the current combined distance score plus 1. So if this had a combined distance score of 2, this would equal 3. Then if this had a combined distance score of 3 and it's less than the range, which equals 4 for this example, then it would get added to the queue because it's within range and added to the list as well. And then after we've checked all of the nodes in the neighbor list for the current, then we add current to our list of active nodes because it's within range of the actor basically. And then after our while loop, we just get rid of our open list and destroy our priority queue. And if you have all this, we can run the game. Oh, actually, just let me show you a sprite. We have a sprite called SBR ISO cell highlight. This is just to highlight the cells. So this one, its first image is to say whether this node is inside the list of active nodes or not. And this one is for displaying parents, although I don't think I use it in this example. So we're just using this one for now. So let's run the game. Space, enter. Wait for the amazing intro to finish. And you can see whatever character we switch to will have nodes it can walk to. If you can see with some of these, so you can see at the moment it looks like you can walk on water. That's because we're not checking for passable or anything like that. We're not checking if height is blocking us. So this character looks like he can jump, really high to these 2 tiles over here. So we shall amend that now. Back into our script, you can see we don't have any yellow marks against these 3 anymore. That's because we're now using them. So we scroll down right underneath where we set the node's parent to current. Right, it's a bit easier. So after here, we set the node's parent to current. We want to check to see if this node is passable and whether impassable is allowed or not. So if this node is not passable and impassable allowed is not allowed, then we're just going to add this node to the list to say, well, we've already checked it, we don't need to do anything with it, it's useless. That's all we do there. That's what it's for. If the node is too high, skip it. So if a node has a height of 8 and this value is 2, which equals 6, and the current height is 4, the current height is 4, then it's too high, skip it. If actors are supposed to block movement, so if actors block is true, and there's an actor in this cell, then add it to the open list. So this is how we're blocking things off. So we've also added this line as well. We just wrapped this code within this check. This is because if either of these three things have happened, then the node's already going to be added to the list. So we don't need to do any of this stuff. That's why we have this check here. So that's all we added. If we run the game again, so you can see now this first character, he can't move there or there. He can go 1, 2, 3, 1, 2, 3. Oh, sorry, my mistake. We need to do one thing. It should be less than or equal to range. It's only giving us 3 squares, but there should be 4. That's why, sorry. So he can go 1, 2, 3, 1, 2, 3, 1, 2, 3. He can't go 1, 2, 3. This guy, he's blocked from moving here, so he can only move around there. Let's get 1. So this guy here, he can't go up there anymore because it's too high. This guy can't go in the water anymore because it's water, and that's it. Okay, so last thing I want to show you today is we're going to be moving a cursor around in the map, and we're going to, whenever we press enter, we're going to generate a path for that particular actor as long as we are pressing enter on a node that is within the list of active nodes. So in the create event of obj test, we want a new queue, priority queue called path queue. This is going to hold a queue of nodes, and they're going to be basically path points. So which nodes should we travel to in which order, and this is where the parents come into play, because we know which node will be the fastest to travel to a different one. Grid X and Grid Y is going to be used for our cursor, for moving our cursor around the map. So then in the step event, inside our inside our in battle region, inside next actor, so we're going to every time we generate a new or we get a new actor, we're going to set the grid X and grid Y for the map to the current actors grid X and grid Y, so it starts on the same square. And then inside actor taking turn, small modification. So we want to press enter to generate a path, but we don't want to change actor when we do that. So we're only going to be changing actor if our cursor matches the same cell that the actor is in. If we press enter and either grid X doesn't equal current actor.gridX or grid Y doesn't equal current actor.grid Y, and this is going to happen. So we're going to have a start node and an end node. Start node is going to be whatever cell the current actor is in. End node is going to be where our cursor is at the moment, grid X, grid Y. We also want to make sure this is a valid node for movement. So if end node is within this list, then it's valid, and we're going to have a new script which is going to generate a path for us. And then this new region here, we're going to use our script to, whenever we press left or right, we're going to update grid X. Whenever we press up or down, we're going to update grid Y. We don't need this. So that's all the changes in the step event of obj test. and then we'll do the script last. So let's do the draw event now. So inside draw cell again, we have a new region. We're going to highlight a node if it's a path node. So is this one of the nodes that's going to be traveled across? So check what node is on this cell. If that node is in this queue, the path queue, then it's a path node. So we're going to highlight it. And then underneath battle unit, we're going to have another new region called draw cursor. What we're going to say is if we are in the state where the actor is taking their turn, and in our double for loop, if XX equals grid X and YY equals grid Y, then this is our cursor cell. So draw the cursor. And then finally, SCR generate path. So it's going to ask for a start node, an end node, and the queue that we want to add node to. Clear the queue. Add the end node to the queue because we're going to work backwards. Because this is how we're going to take advantage of the parents, because whatever the parent of the end node is going to be the fastest node to get to the end node, and then whatever the parent of that node is going to be the fastest, and so on and so on, and eventually we'll get to the start node that way. We're going to set our current node as the end node, and we're going to add that to the queue. Don't need this. And while current is not equal to start node, we're just going to get the size of the priority queue, which is going to increase as we add more nodes to it. And basically we're just going to be adding the parents of the nodes to the queue until we get to the start node. It's that easy. It's that simple. As soon as current equals the start node, this will break and we will have our queue. So now we can run the game. So if I press left, right, up or down, I can move this cursor around. If I press enter while I'm on top of the character, it goes to a new character. If I want to see a path, if I press enter, you can see all these path nodes are highlighted like that. If I want to move there, here, what about on the other side of this character? See, it goes around him. 1, 2, 3, 4. Oops. 1, 2, 3, 4, like that. Move there, can move there. The only thing that we're not doing today is we're not having the actual characters move because I ran out of time. Sorry about that. So you should have something like this. You know, you should be able to see a path of nodes where, you know, this looks like the shortest path. That's it. Thank you for watching, and I will catch you next time. Bye for now.